In a Young's double slit bichromatic light of wavelengths 400 nanometer and 560 nanometer are used. The distance between the slits is 0.1 millimeter and the distance between the plane of the slits and screen is 1 meter. The minimum distance between two successive regions of complete darkness is, complete darkness means it is dark fringes, that's all. So what is the general formula? Nth minima coincides with mth minima, complete two successive regions of complete darkness. So these waves, if initially 400 nanometer will give you more fringes, okay, this is one position of darkness that coincides with the bigger fringe. So this is nth minima coincides with mth minima of the other. Okay, so that is what we need to calculate. So if this has got a wavelength 400 nanometer, because number of fringes is more, then wavelength should be less, 400 nanometer. This lambda dash is 560 nanometer. So this is the position xn. So first of all, nth minima coincides with mth minima. So that is 2n minus 1 lambda by 2 should be at the position xn. Of course, that is d by d, and this is 2m minus 1 lambda dash by 2, the position d by d. So d by d cancels off. Now by 2 cancels off. 2n minus 1 by 2m minus 1 is lambda dash by lambda. So what is lambda dash? Lambda dash is 560 nanometer. This is 400 nanometer. So when we calculate, this will come around. This is 4 tenza. This is 4 14za. This is 4 14za. Okay. Now that is a reason. That is what we are going to get here. 14 by 10. So that can be rewritten as 7 by 5. So that goes as 5 into 2n minus 1 is equal to 7 into 2m minus 1. So 10n minus 5 is equal to 14m minus 7. So n by m, if you want to take, what we got to do is we need to bring them 10n, as this 7 comes to this side, that will be plus 2 is equal to 14m, plus 2 14m. So location of the minima m by n ratio we need to find. M by n ratio we need to find. That is the challenge that we associate, or else we can directly substitute also. We can directly write it as 2n minus 1 is 7, 2m minus 1 is 5. So when that happens, 2n is 8, n is 4, here 2m is 6, m is 3. So third minima of 560 nanometer coincides with fourth minima. of fourth minima of say what is the wavelength? 400 nanometer. So the location is x3 is equal to 2m minus 1 lambda dash d by d. So whether the distance, yes, they are given. So it is 2m minus 1 is 5 into 560 nanometer into 1 divided by 0.1 into 10 to the power minus 3. So that is a location. So x3 if I calculate, that will come around 5 into 560 into 10 to the power minus 9 into 1 divided by 1 into 10 to the power minus 4. This cancels with 10 to the power minus 5 it is. So 560, that will become 2800 into 10 to the power minus 5, 28 millimeter is a location. 28 millimeter is a required location. So that is option D. The location is 28 millimeter, hence option D is the right answer.